We studied the motion of an object in the XY system, in the Cartesian system. Now we'll be studying the motion of the object in NT system. This is what we call finite system. So we'll study this motion means studying the position, the velocity, and the acceleration. So first we'll define what we mean by this system. So if you notice here, you have an object moving on a curvilinear trajectory. So first, in order to talk about a system, we must have an origin. The origin of this system is O here, which is a fixed point. Now, it's a system, so a curvilinear system is a system which moves with the particle. This is the first difference between the NT system and the Cartesian system. The Cartesian system ij is fixed, while here the NT system is a moving system with the object. It has two unitary vectors, which are ut, this is the tangent, the unit vector tangent to the trajectory, and which is with the motion always. So we notice here, if we want to trace, for example, ut at the point m2, it's with the motion and tangent. So here also, it's tangent and with the motion, etc. So at any point, in order to trace ut, we trace it tangent to the trajectory and with the motion. Now un vector is a unit vector, but which is normal to the trajectory, and this is what we call perpendicular to ut. So it's perpendicular to ut. Now it can be, for example, outside, but since we have here a perpendicular can be, for example, from this side. But the definition of the unit vector normal is that it's always directed toward the center of the curve, the center of the trajectory. So here, as if we have here the center of this curve, then un is directed toward the center. Now we begin our study by studying the position, the curvilinear position, or what you call the curvilinear abscissa. Is the same thing. So here, in order to study the position, always in order to start from the position, we talk from the point O. So here is the position of the particle at a certain instant. It's determined by the algebraic value, which is called OM. So here OM is an arc. Example, if we want to find the position at T2, then it's OM2. If we want to find the position at the time T5, then it's OM5. These are values. These are values in length in meter. So this is what we call arc, OM2, OM5, and it's called the curvilinear abscissa. Displacement. So as we know, displacement is the variation of the position in terms of the time. So displacement. So as we know, the displacement is the variation of position between two instants. So it's given by m initial, m final equal to delta s. So it's s final minus initial. The difference, the variation between the position. Example, if we want to find the displacement between m2 and m6, so it's m2, m6. It's an arc which is equal to OM2, OM6 minus OM2. This is what we call delta s, s6 minus s2. Now, what do we mean by velocity vector? How to find the velocity vector in this system? The definition of the velocity won't change, will remain the same. So as definition, it's the variation of the curvilinear position during a certain interval of time. So here V, it's a displacement. It's the variation of curvilinear position over the time. So it's s final minus s initial over t final minus t initial. We saw in the part Cartesian system V vector equal delta r over delta t. So what we changed, it's the position vector into a curvilinear position s. If you want to talk about an instantaneous speed, then in this case, this interval of time must tend to 0. This is how we write it. So v equal limit when delta t tends to 0, which will become ds over dt, and this is what we call the derivative of s. Then v equal s prime is the derivative of the curvilinear position. Here on the figure, if we want, for example, to find now the vector, v vector. So in this system, we find first the value and then we deduce the vector. We know that in order to trace a velocity vector, we trace it always tangent to the trajectory. So here, for example, this is v2, this is v7, same thing at v11 at any other point. We trace it tangent. Since we trace tangent, then we know that the velocity vector is always along ut. It cannot be along un. It's tangent, so it's along the unit vector, the tangent unit vector. So this is how to write the vector v. Now so this is a summary here. V value equal s prime, v vector equal to this value along ut is then times ut. Now for the acceleration vector, is that the acceleration vector along un always or along ut always. This is what we will find. So how to express the acceleration vector in the curvilinear system? If you notice here in the figure, we have to find, for example, if we want, for example, to find a2, okay, as definition we know that a2 vector is equal to delta v over delta t, and this is what we call v3 minus v1 over delta t. If we notice, we want to trace v3 minus v1 at the point m2. So this is v3 here, نقلناه على هون, this is v3 minus v2, so this is the vector minus v1, sorry, so this is the vector v1. We want an opposite, it's minus v1, then this is minus v1. The summation of these two vectors means v3 plus minus v1. It will give us this vector delta v. Now a2 is on this vector since it's having same direction and same line of action. It doesn't for the value, it's not necessary to have the same value since we have over delta t. Now if we notice here, a2 vector, it's not only along a2 vector is not only along at, and a2 vector is not also only along an, it's oblique. Oblique, this means it has two components, لهن at and an. So how to write the acceleration vector? It's written by a vector equal an, the component along un, plus at, the component of a along ut, such that an and at are two rules to study. Means an equal v square over r, it's the speed, the value of the speed over r, and at equal the derivative of v. We notice here, it's very important to notice it's the derivative of the value v, and it's not the derivative of the vector. So this is called the normal acceleration, this is called the tangential acceleration. So in this case, in order to find a as whole value, a equal radical an square plus at square. Here, if you notice now here, if you will observe this animation, you will notice that v is always tangent to the trajectory, but the direction of a is changing. Marga can't with at, marga with an, another time it's oblique. It has the two components. So this is for v and a, the direction. It's equals to st is equals to 2t square minus t plus 4. We have a particle m moving along this curvilinear position. The first question is determine position of m at t0 equals to 0 and at t1 equals to 1. So but as simple as it is, we substitute t0 equals to 0 in the equation, and then we can find s at t equals to 0. Now part 2a, it's determine the speed v at any instant and deduce the velocity vector. In order to find the speed v, we know that v equals to s prime. Then here are the answers. At t0 equals to 0, this is s0, we find it by substitution. At t1 equals to 1, the same thing. And SI unit is in meter. Now, part 2a, the questions find the speed, the value of the velocity, means the speed. So we know that at any instant, so it's instantaneous. Then v equal s prime. We do the derivative of s. This is s. So we do the derivative. It will be 4t minus 1. As vector, it's always along ut. Then v vector equal 4t minus 1 along ut. Now in the part B, the question is deduce then the vector v at t equal 1 second. So at t equals 1 second, so here محل t we substitute 1, it will be 4 minus 1, then it will be 3 ut. This will be the vector v1. Now we continue. In this part 3, the question was to find the acceleration, the normal acceleration and the tangential acceleration at t equal 1 second. In order to find the normal, we apply the rule an equal v square over r, but we need it at t equal 1 second, and we have v1 at t equal 1 second is 3. So we substitute here by 3. It will be 3 square over 2, then it's 4.5 meter per second square. As for at, in order to find the tangential acceleration, is equal to the derivative of v value. We have, this is v, we found it, then its derivative would be 4 meter per second square. Now deduce the value of a as total, a equal radical an square plus at square, then this will be the value a1. Now in the part 4, the question is to write the acceleration vector in terms of un and ut, means we want to write the vector. So in order to write the vector, it's a n un plus a to ut. We have an, we have at at equal 1 second, then we only substitute.